Now children, in the previous class I had told you that the Earth's axis is tilted at an angle of 66.5 degree to the orbital plane. Now this angle is fixed. As you can see in this diagram, the Earth remains tilted in the same direction throughout the year. Its inclination is fixed. So this is referred to as the inclination of the Earth's axis. So in this diagram, if you see, as the Earth continues to revolve around the Sun, the angle remains the same. So because of this revolution and because of the tilted axis, the seasons are created. So children, a very important consequence of the revolution of the Earth on its tilted axis is the creation of seasons. So in this diagram again, I'm going to tell you that in the month of June, when the northern hemisphere is tilted towards the sun, so during that time it is summer for the northern hemisphere. There are more hours of sunlight, and when we see the December position, during that time what happens is that the southern hemisphere experiences the summer season, so it has more hours of sunlight and the temperature is also more. So because of revolution on an inclined axis, the seasonal changes are not abrupt. It's not that today is winter and tomorrow all of a sudden it becomes summer. The changes, the seasonal changes happen gradually as the Earth continues to revolve around the Sun in an inclined axis. So the path along which the Earth travels around the Sun is called the orbit. Now in this diagram, as you can see, the orbit is elliptical or oval in shape. As a result, the distance of the Earth from the Sun changes constantly during its revolution. So there is a phenomena called perihelion and aphelion. So what happens is, when the Earth is closest to the Sun, that position is referred to as perihelion. So the word perihelion comes from the Greek word peri, which means near or around, and helios meaning sun. So perihelion is a time of the year when the Earth is closest to the Sun. It occurs every year on 3rd January and the distance is 147.3 million kilometers. Now aphelion, the word aphelion comes from the Greek word ap, which means away from, and helios means the sun. So during this time, as you can see, that the distance between the sun and the earth increases to about 152 million kilometers, and it occurs on July 4th. Now the average distance between Earth and the Sun is about 150 million kilometers. Since the Earth orbit is elliptical, the distance of the Sun from the Earth varies about 2.5 million kilometers from the average. Now these differences in distances during perihelion and aphelion are small when compared to the great distance between the Earth and the Sun, and therefore it is not the cause for seasons. Now it should be noted that Earth is closest to the Sun in winter. Can you see 3rd January? And obviously this is not the cause of the season. So perihelion and aphelion has nothing to do with the seasons, because it is mainly the inclined axis and the revolution which are actually responsible for creating the seasons. The spherical shape of the Earth, along with its movement around the Sun in a tilted axis, causes the difference in the angles at which the Sun's rays fall on the Earth's surface. So you can see this diagram also. Because of the difference in the distribution of heat on the Earth's surface, the world has been divided into 3 heat zones. So the direct rays, as you can see, they fall at the equator. Because of the direct rays of the sun, the Equator is the hottest area. So, thus, as we move from equator to the poles, we come across regions with varying temperatures. These are called the temperature zones or the heat zones of the world. So, the first is the Torrid Zone. This zone lies between the equator and the Tropic of Cancer and Capricorn. So, here the rays of the sun fall vertically almost throughout the year. So, the direct rays of the sun fall over a small area, giving it a greater amount of heat. Thus, the temperature in this region is high. The temperate zone or the moderate zone, it lies between the Tropic of Cancer and the Arctic Circle in the northern hemisphere and the Tropic of Capricorn and the Antarctic Circle in the southern hemisphere. The temperature in this zone is moderate since the rays of the sun fall at a slanting angle in this region. Then next we have is the Frigid Zone. This region extends from the Arctic Circle to the North Pole in the northern hemisphere and the Antarctic Circle to the South Pole in the southern hemisphere. The rays of the sun are slanting, which means that they spread over a larger area. The slanting rays obviously have a lesser heating capacity as compared to the vertical rays. The vertical rays, they are focused, they are concentrated over a smaller area, so their heating capacity is more than the slanting rays which spread over a large area. So children, just to explain the difference in heating capacity of the slanting and the vertical rays. Now the slanting rays, when they are because they are focused over a small area, so they have a greater heating capacity. Whereas the slanting rays, they spread over a larger area, so they have less heating capacity. Take the example of a magnifying glass. On a sunny day, if you take a magnifying glass and you focus it on paper, after some time you see that the paper starts to burn because the rays of the sun have been focused over a small area of paper. And the moment you start slanting the magnifying glass, the paper will not burn at all. So is the case with the sun rays also. So in the areas around the equator, that is between the equator and the tropics, the rays of the sun are direct and focused, so they have greater heating capacity. Whereas as we move towards the poles, the rays become more and more slanting, and as a result of this, their heating capacity is also less. So the temperature is higher in the lower latitudes as compared to the higher latitudes. Now children, in the previous class I had told you that the Earth's axis is tilted at an angle of 66.5 degree to the orbital plane. Now this angle is fixed. As you can see in this diagram, the Earth remains tilted in the same direction throughout the year. Its inclination is fixed. So this is referred to as the inclination of the Earth's axis. So in this diagram, if you see, as the Earth continues to revolve around the sun, the angle remains the same. So because of this revolution and because of the tilted axis, the seasons are created.